So in this example, we're given a pretty simple network here, and we have two independent voltage sources here, and then we have a current-controlled dependent voltage source here. We're told that this current here, I2, is equal to 10 amps, and we're asked to see if we can calculate what the value of R would be under these conditions. So let's go about this, see how this works. So we're going to start out by doing a voltage loop analysis. And so we're going to start out by looking at this loop here. So for this loop here, we're going to run down the list here. So the first thing we see is this voltage source here, and let's define a direction. So we're going to go around the loop in this direction. And when we look at that, we see that we encounter the negative sign first, so we'll say negative 50. And then as we come around the loop here, we see we encounter this 10 ohm resistor, and the current we're assuming is going in the same direction as our calculation, so then that'll be a positive 10 times I2. And then as we continue around the loop, we see we encounter our dependent voltage source. And so again, we encounter the negative sign first, so it's minus 5I1. And then we know if we sum all those up, that should equal to 0. Now we recall that we were told up here that I2 is equal to 10, so then we will substitute that directly into here. So let's start to calculate this out. So rewriting this, that'd be minus 50 plus 10 times 10, the value of I2, minus 5I1 equal to 0. So this will be minus 50 plus 100. And well, we can move this to this I1 term to the other side, so that'll be 5I1. If we just add 5I1 to both sides. So now this becomes 50 is equal to 5I1. And so finally, dividing both sides by 5, we see that I1 is equal to 10 amps. So I1 is equal to 10 amps. So that's fine, and that's we will use that in the next part of the problem. So now we want to go back to our network here, and now we want to look at the loop on this side, this loop here. So let's do that, and again, we're going to look in this direction, go around the loop in this direction. So let's start out with that. So the first thing we're going to encounter is this voltage source here. And when we do, we see we hit the plus sign first, so that'll be 10 for 10 volts. Then as we come around the loop, we'll come around this way, we see we encounter our dependent voltage source. And so we'll do that in blue here to correspond with this. So that's going to be plus, because we hit the plus sign first, 5I1. And then as we continue around the loop this way, we see that we then come in contact with this resistor here, R. And the current flow is going against, the assumed current flow is going against where the direction we're going. So then this will need to be negative, so it'll be minus I1 times R. And so we should be able to set all of this equal to 0. But we recall that we already know or calculated the value of I1, so we'll substitute that in both of these places. So let's do that. So now we'll have 10 plus 5 times 10, the value of I1, minus 10R, and that's going to equal to 0. So now we're going to add 10R to both sides, so that'll get our 10R over here, and then this is 10 plus 50, so now we have 10R is equal to 60, so R was equal to 6. So that's the value of R, 6 ohms.